Good afternoon to you all. We are going to restart our work with a presentation, test site for marine renewables, by Julián Cabana Gandiaga. Julián Cabana, from a very young age, had a great passion for the ocean and everything related to it, which is why his dream is always to become a marine biologist. He did his academic studies at the University of Las Palmas de Gran Canaria, where he graduated in marine sciences, and later at the University of La Laguna, where he did a master's degree in marine biology, biodiversity and conservation. He has carried out different types of work related to the sea, from working with marine mammals and fish in aquariums, to cetacean research campaigns, aquaculture, research projects and endangered marine species, until the present day, currently at PLOCAN, the oceanic platform of the Canary Islands. Julián Cabana.
Hello everyone. First of all, thank you for having me here. It's a pleasure to me to be here. And let's start with the presentation. I'm here today on PLOCAN's behalf to talk to you a little bit about what PLOCAN is and what are the possibilities that we offer to the sustainable energies world. Let's start telling you real quick what PLOCAN is. The Ocean Platform of the Canary Islands is a public consortium created in 2007 between two public figures, the Ministry of Economy, Industry and Competitiveness and the government of the Canary Islands, with just one goal. This goal was to build a set of marine infrastructures to research in the field of marine sciences and technologies. PLOCAN has a mission. It's simple. This mission is to provide a cost-effective combination of services that respond to the upcoming scientific challenges and the socio-economic needs of the ocean. As you can see, this mission can be summarized in 4 points. The number one is offer new services and facilities, especially in the marine sector, including improvements in operations and capabilities demanded by the scientific community and the industry. The number two is to provide standardized and accessible data, promoting in this way the sustainable observation of the Central Atlantic. The number three is offer an agile, flexible, and a good organization capable of responding in an efficient way to the unique challenges. At the number four, it's increase that socio-economic impact, increase that engagement of the stakeholders, and very important as well, increase that diffusion of the knowledge and also the technology developed in society. Let's talk about PLOCAN structure. PLOCAN is not just one facility, okay? It's made up by different ones, okay? Which together make up one of the most complete marine research investigation platforms nowadays. It's formed by a land-based headquarters, an ocean test site, of an offshore platform, the BIMAS, which is the unit of underwater vehicles, instruments and machines, and also an ocean observatory. I'm going to start with the land-based headquarters. It's ubicated at the east of Gran Canaria Island. This onshore facility has 400 square meters of, between others, equipped areas for electronic and mechanical integration, storage, and logistics, different kind of labs, including one with a saltwater tank, and also areas for piloting marine vehicles, and of course, areas to support different scientific activities. And now I think this is a very important and very interesting thing to talk about today here, is the PLOCAN Ocean Test Site. As you can see in the picture, it is a 23 square kilometer ocean test site for marine technologies for multiple natures, okay? It was created to accelerate the knowledge, the sustainable and responsible use of the marine environment. Offers what? Offering observation systems and, I think, a very important thing, open ocean in real conditions. Always agreed with the Sustainable Development Goals. It is equipped underwater, under the surface of this sea test site. There is an electrical and communication infrastructure consisting in 2 medium voltage cables, which allow of 5 megawatts each one, which allow the connection of the new technologies that generate energy from the natural resources. In this picture, you can see in a more technical way how the underwater morphology of our test site is, and at the same time, you can see the infinite possibilities that it offers. In this little circle here, you can see the offshore platform, which I'm gonna check right now. This is the PLOCAN offshore platform. It is located 1.5 kilometers off the northeast coast of Gran Canaria Island and is resting on the sea bottom at 30 meters deep. It offers, as you can see, multidisciplinary laboratories and hangar equipped to load and unload materials for experimental tests or experimental projects, as well as maximum capacity for 40 people, 15 rooms, restrooms, kitchen. It's a platform who is gonna cover any need of any project or prototype that is working on the test site. It's important to mention as well the grid of the offshore platform called a smart grid. The main function of this electrical and communication infrastructure is to evacuate and supply the electricity generated all around the trial bank to the transmission grid, as well as transmit data in real time to further analysis or processing. PLOCAN's smart grid supports, of course, experiments or trials of new technologies that use, again, natural resources to generate electricity. We're talking about wind energies, ocean energies, okay? And in this picture, you can see an example of how this smart grid works and how are the connections underwater of the prototypes of new technologies to the grid of the platform. The VMAS, as I said before, this is a base for that devices, underwater vehicles and devices for visualizations at different depths. In this picture, you can observe some of the toys that PLOCAN has to offer to the different projects or prototypes that are in the trial bank or outside it. And for last, an ocean observatory. This is a permanent ocean platform for monitoring and controlling the marine environment, and also to have a control and have data about how is doing our underwater test site and the underwater test site. Okay, after this brief explanation of what PLOCAN is, let's talk a bit about the projects that have made use of our trial bank, okay? All the prototypes you are gonna see from now on have been tested or will be tested in the PLOCAN test site. We're gonna start with the wind turbine of the Helican project, okay? A telescopic wind turbine. This prototype was tested in the PLOCAN in Gran Canaria in 2019. It was the first offshore wind turbine in Southern Europe powering electricity to the grid. In this case, Gran Canaria grid, and is still, as you can see, is still powering the Gran Canaria grid from 2019. It's important because it's the basis for other marine renewable energies projects. Now we pass to the Pivot Buoy project. This is another wind turbine, but they developed a self-orientating floating wind turbine. Okay, this system is supposed to reduce the total cost in a significant number, making the wind turbines competitive. This technology will be able to be installed in deeper waters than the currently floating solutions, opening a lot of possibilities that were previously technically or commercially inaccessible. It was tested during 1 year, and this phase of testing finished just 1 month ago, the last month, where they complete that 1 full year testing. In this case, another wind turbine, but with a couple of twins wind turbine of 6 megawatts each one. They wanted to prove the functionality, stability, and survivability in real conditions, and I think that there's no better place than the northeast coast of Gran Canaria, where our test site is, a winter in this place to test the functionality of any prototype. Changing the subject a little bit, we are not talking about here about a wind turbine. We are talking about a platform to support a wind turbine developed by the PLOCAN project. Okay. In this case, this prototype was not tested in Gran Canaria. 2 numerical simulations were done, one with the data of Juan Grande in Gran Canaria and the other one with the data of Scotland. After that, they did a real simulation in a facility specialized in the hydrodynamic experience channel in Marine in Holland, where this real simulation in a scale were done. In this case, they developed a lighter anti-fouling and anti-vibe power cables who are supposed to reduce the maintenance cost. How? These anti-fouling and anti-vibe components are included inside the matrix of the polymer, so it's going to reduce a lot of cost of maintenance. Now we are going to start with Ocean Energies at PLOCAN. You can see some examples of wave energy converters here. A huge buoy from the Undigen project in 2013, and another one here in the Welcome project in 2011. 2 buoy wave energy converters prototypes that use the waters of Gran Canaria test site of PLOCAN to prove their resistance. In this case, the Wello project is a little bit different from the conventional buoys. In this case, the first concept of their prototype was done in PLOCAN waters. It's an asymmetric shape who struck the energy from the waves crashing into it from all the device. And they are going to prove again another prototype in a future in PLOCAN. The wave piston project, again, you can see a picture here about the prototype being tested there, the Helican wind turbine behind, and here you see an underwater photo picture of the structure of the device. You can see those plates move back and forth because of the movement of the waves, and suck the water into a pipe, this pipe here, and this pressure water comes through this pipe to a final device or plant who is going to produce electricity with this pressure water. At the same time, they are going to use that electricity produced by that pressure water to run a desalination process offshore. So it's for that this was the first prototype tested in PLOCAN, and in the future they are going to prove another one with a desalination plant included in this prototype. Same thing at the Oceanosis project. In this case, this device is already in the port in Gran Canaria, but the the tested phase is going to be executed in the future. Works, okay, like the before the wave piston project. In this case, it's a mobile floating desalination plant that uses the wave power to transform that ocean water in fresh water using the electricity obtained by the waves. In this case, changing the subject a little bit, the BOOST project, we're talking about floating solar panels for open waters. In this case, this developed a new system inspired in the Norway aquaculture sector flotation and mooring technology combined with a patented hydroelastic membrane. This membrane works protecting that panels from the humidity, which is the most dangerous thing for the panels, but at the same time, this technology keep cooling the panels, as you know, to get the job done correctly. And the last one here is the Global OTEC project. As you can see in the presentation, this project is in prototype construction phase and it will be tested at the PLOCAN trial bank in the future. What does it mean? That they are just going to test the structure, the resistance, and in the waters of PLOCAN because they cannot produce electricity there. This is a device to obtain the electricity between the gradient of the temperature gradient in between two bodies of water, surface water and depth water. So in Canary Islands, we don't have that difference between two bodies of water. It is possible, indeed, in tropical waters. So in this case, they are just gonna prove their device against the conditions, the hard conditions of the waters of the Canary Islands. And this is all. Thank you so much.
Is there any question from the audience? There's a question from Francisco Tencourt from Atlantic Line.
Hello, thank you for the presentation. It's just a question that it goes with me a long time ago. Is this possible in the Atlantic? Because this is Mediterranean, and this is possible to do that in the Atlantic with the problems with Atlantic?
What thing?
The wind.
The wind.
Yeah.
We are Canary Islands are in the Atlantic, Central Atlantic. We are. Yeah.
But lower in the Atlantic. In the North Atlantic, is it possible?
Oh, in the north. Yeah. Of course, they are right now wind turbines, aeolic energies in the North Atlantic, of course, right now. Yeah.
There's another question from Edda. Just a moment, please, for the people that are listening to us on YouTube. Thank you.
What's the power installed in that project?
What?
Power installed. How much they produce, energy they produce?
In the platform?
Those projects that you were talking about. That one, the previous one.
They are the prototypes that are using natural resources to generate electricity. But the support is in the platform. This platform offshore.
How much power in the previous?
Depends. What?
This one, that one, and the other one.
What?
These
two?
Yes.
Okay. I don't know the answer of this question, but I can ask my college, and then you have my. Then okay, and I can answer you.
No more questions? that's okay. Thank you, Julián.
Thank you.
Well, we will continue with the first presentation that was scheduled for this afternoon. Getting back for the normal course of this seminar program. For now, we are going to have Cristian Menéndez with engineering solutions for renewables at ports. Cristian Menéndez Fernandez is from Asturias in Spain. He studied a double degree in mining and energy resources engineering and civil engineering between 2015 and 2020 in the University of Oviedo. Then studied the Master of Science in Civil Engineering in the University of Oviedo also between 2020 and 2022. Currently, he is working full-time in SAFIER Ingenierie, a French engineering consultancy in the offshore structures field. And he is also doing partial time and PhD in natural resources engineering in the University of Oviedo. Cristian Menéndez.
For the presentation, I'm going to talk to you about the engineering solutions for renewables at ports. First of all, I'm going to present the company, SAFIER Ingenierie. As he said, it is a French company. Then I'm going to talk about the floating offshore wind turbine needs in the future, and then present some of the projects that we are coming across, and finally talk about just an overview of very large floating structures, which is the topic of my PhD. So, first of all, who we are. Here you can see several photos of the team. We are a cross-energy engineering deep technical solutions consultancy. We are more or less 60 full-time engineers. Some of them are working in clients' offices, some of them are working in internal projects. These internal projects are innovation projects which try to be safe, economic, and industrialize low-carbon engineering. And we've been for 40 years serving the clients with the core values that are these ones that I present here: ethics, morality, technical, transparency, and pride in the work. So, as all of us are engineers, we say that the engineering team is the company, and also that the company is the engineering team. The expertise of the company is all of these topics that you can see here in the image, all of them in the offshore field. We have been working for 40 years in the oil and gas industry, and now we are also in renewables, hydrogen, and whatever related to offshore structures or offshore energies. So, regarding floating offshore wind turbines, needs in the future, the objectives for the European Union for 2030 is to have 7 gigawatts of floating offshore wind energy in Europe and 60 gigawatts of mixed fixed and floating offshore wind. So that means that more than 7,000 of floating offshore wind turbines need to be constructed, and the ports probably they don't have that space to fulfill the requirements of the target. So our opinion is to go floating and do the construction, the assembly in the sea, in a floating platform. But first of all, to come to this platform, I'm going to present some of the projects that gradually set the way of the company to go to these floating solutions. First of all, this patent, that is the C2C connection, it is an assembly method for floating concrete caissons. So it is a real connection between floating concrete caissons, and with that you can construct port infrastructures, you can construct a marine offshore platform, and even it can be used in submerged floating tunnels that probably in the future, even if it is not in the energy, they will have some importance in the offshore industry. This project is a floater for wind turbines. It's done in concrete with this C2C connection. The construction of this floater is really safe because no divers are needed. It is economical because it can be industrialized, and it has the code conformity because all the work done is with the conformity of the DNV codes. This platform is the Blue Growth Farm. It's a fish farm. It's a platform that is, as you can see, 200 meters by 100 meters. This idea came because of the rising sea level problem. Also, the desertic zones are increasing, and probably in the future we are going to have food shortage. So one of the solutions could be go into the sea and produce food in a sustainable way, environmentally friendly, totally renewable energy with wind turbines or wave energy converters. And now we are working in this with the partners of CETEC, which is a French company with expertise in civil engineering. This platform is said to be an assembly platform for the offshore wind turbines, floating offshore wind turbines, sorry. And the reason, as I said before, it is the largest space required, that if we don't have in the earth, so we go into the sea. This platform is to be installed in sheltered areas, not in the open sea, because of its hugeness. It is difficult to resist the big waves in the open sea. So this is one of the innovative solutions to fulfill the objectives of the European Union and energy, floating wind energy. It can be used not only for this assembly line, it can also be used as a living area, transformer platforms that are going to be needed in the floating offshore wind farms, also for hydrogen production, and even for small nuclear reactors. The layout can be standalone, it can be in a community of several marine offshore platforms, or it can be attached to an existing quay as the enlargement of the port. This various configuration is possible because of the modularity. As you can see in the image, several caissons are attached, so you can attach caissons as much as it is necessary for the goal of the platform. And then it can be reused when it finishes the industrial life, as in this case a smart city, but well, this is a future project to come. This photo that I put here to talk about very large floating structures is NARC, is a Japanese project that the company is in contact with. So with the solutions that we can do, things like that are possible in the future. So, as I said before, I'm doing a PhD in this type of structures. The principle of very large floating structures is that they are very large, with very long, very big lengths. These platforms can be used for industrial, civil engineering, for military, or even for farms, as I said before with the Blue Growth Farm. But one of the problems, or the biggest questions, are how we connect them to receive the forces, the materials, and those things. So that will be the topic of the PhD. I have, from the little research that I have done in this very first year of the PhD, that the first project of this, the first patent, was done by Mr. Armstrong in 1924. So you can see that almost 100 years that the first idea of very large floating structure has come to a person with the sea station. He continued working for 20 years on this, or more than 20 years on this, but I don't have any photo of sea station or sea drone project. I'm sorry for that. But as usual, the military needs are the ones who increase the need of this technology. So the mobile offshore base, that is the one in the picture, was a project done by the Army of the United States. This was constructed with different modules, modules of between 220 and 500 meters long, and 120 and 170 meters of width. And it can have operation as an airport, a floating airport, with an HS of 1.9 meters and a period of 9 seconds. Another project that was constructed between 1995 and the year 2000, it was Megafloat in Japan. About 5 years, more or less, took the construction of this experimental phase. It was a modular-based structure, and this project proved the feasibility of this type of structures. So the scope of the PhD, that is an industrial PhD between SAFIER Ingenierie, SAFINTAS in this case, that is the office in Spain, and the University of Oviedo, is to design and optimize a very large floating structures. The keys are the geometry, the hydrodynamic and structural analysis, and then in the end to do an optimization of the platform and study the behavior of this platform in different conditions and try to predict the forces on the connection. So just to finalize, I have this slide here that was more dedicated to probably students, but even if you would like to work in this company, you can send your CV to this email that I have in the bottom part of the slide. So thank you very much, and I would like to say a special thank you to Mario Lopez and the University of Oviedo team, that are the ones who bring us here to Azores. Thank you very much.
As we did before, we are going to open a few minutes for questions from the audience. Any question, please sign with your hand. No questions? Thank you.
Thank you very much.
We are now continuing with a presentation on a Belgian case study, Climate Change Mitigation and Adaptation in Seaports, Belgian case study by Luciana das Neves. Luciana das Neves has over 20 years of experience in the planning and designing of climate-resilient coastal infrastructure. She has worked in more than 30 countries on engineering projects related to strategic investment in coastal and port infrastructure development, as well as urban resilience and blue energy. Prior to joining to the International Marine and Dredging Consultants, Luciana has worked as a civil engineer and as a researcher in the domains of coastal risk assessment and management at the Porto University. A Portuguese national, Luciana is a graduate from the University of Porto, where she is still teaching by invitation in the fields of coastal and offshore engineering. Luciana das Neves.
Thank you very much. Yeah, you have to bear with my CV. It's 20 years of experience, so it's a bit long. I would like also to start by acknowledging the Portos dos Açores for this very interesting and very warm welcoming in the island. It's actually my first time, and I'm really enjoying it. So thank you very much. So my presentation is about climate change mitigation and adaptation. You will see that I will very quickly change to adaptation because yeah, I have a soft spot for adaptation. But of course, both are very, very important. So these are two major approaches for climate change. You need to have, of course, reduction of greenhouse gas emissions, but you also need the part on adaptation. And so we will need to adjust our facilities to cope with sea level rise and more intense events in the future. And therefore, we also this morning, we heard about the need to adjust our facilities, our port facility for different fuels. So it's also a good opportunity to check the vulnerability of our ports to see whether we can couple these two. So adapting the facility for new energy sources, but also to cope with what is expected as more intense climate impacts in the future. So as I put it here, they are very intertwined and they are integral part for sustainability. So you can't have one without the other. And evidence shows that while we are making some progress in terms of mitigation, we still need a lot of work on adaptation. And first, there is overall a general lack of awareness and understanding of what are the climate adaptation impacts in terms of the maritime sector. There's also knowledge gaps, how we, for one hand, we need to protect our ports, but on the other hand, if we protect too much, then we are also hindering operations. So there's a bit of a difficult balance between both, and there's actually a lot of knowledge gaps. And of course, adaptive capacity means also knowing what is the context of your port. You need to know what are the vulnerabilities of your port, and you need to adapt to that. And of course, we talk about a lot during this morning about stakeholder engagement, and indeed, in the case of ports, in the case of all the ecosystem around the ports, which is very large, and not only on the port itself, but also on the supply chains and so on and so forth, stakeholders need to be involved. And this project that I'm going to speak about, it's all about that. So it's all about climate adaptation of ports. And I take this example of Hurricane Sandy, which I think it was one of the events, recent events, that shed the light of how disruptive a climate event can have on a port. And most important that I want to highlight is this 8 years that, not so much, 8 days that the port was that could not operate. And not only the huge impact in terms of economics, but 8 days, it's a lot, plus all the damages associated to this event. And this event, I think it was a breakthrough that shed the light that this critical infrastructure is very vulnerable to climate impacts. And these climate impacts were also compounded by other climate impacts, so it was not just sea level rise and storm surge, or storm surge in this case, but it was also the fact that other climate hazards like freezing temperatures also compounded to even increase the impact of this event. And of course, billions of dollars not only for the ports, but over the entire city, and we're probably just looking at direct impacts. We all know about this huge protection done in the Netherlands in the past, but I don't want to shed a light on this. I want to shed a light on the new approaches. So, of course, you need all this protection. In the case of the Netherlands, not everywhere you need this, but we are also looking more and more towards different types of adaptation strategies. So we are looking at accommodation strategies more and more, so seal buildings, flood-proofing of buildings, early warning systems so that you can prepare for the events. I think that's a very easy and very effective way of reducing the damages and the impact. Of course, moving assets to elevated locations, using floating quay walls, compartmentalization. You also can elevate the building floors. And of course, you have all the normal or more traditional, and you need them. You need protection from dikes. You need, in some locations, you really need to raise your quay walls. And eventually you also need to raise your port terrains. But because there is a lot of uncertainty of how much and by when sea level rise will reach, then you need new approaches for this. And then I give you some examples of the ports of Hamburg, where you have a coastal protection where you, a flood protection where you almost can't see it on a normal day. You see also the buildings are sealed, or you can have more green infrastructure together with the port protection, and the case of Antwerp, where you have also a dike which is seemingly integrated into the landscape. You almost don't see the protection. But the project I want to present you is Kustvisie. It's a project that we have been working at IMDC since 2017, so it's already 6 years, and it's going to continue. We are now on the second phase, which will end in 2025. It's a project, it's a big project, so it's about all over the entire coast of Belgium, and including the seaports. It's a project of, the second phase is about 7.7 million euros just for studies, so it's a lot only for studies. And the first phase was about the same dimension. So what is the aim? The aim is to develop a vision to keep protecting the entire coast of Belgium against flooding, also in the future. And we are looking at sea level rise from 1 meter to 3 meters. And how do we do this? So together with stakeholders, we define the required space. So it's very important to look at the space requirements. If you want to have protections that are less visible, so you don't want a barrier in your city, if you want this, then you need to check the space that you have and also the roadmap to adapt it. And why? The idea is that everyone should be able to enjoy the coast in the future. I'm talking a lot about the coast, but the weakest spots in the Belgium coast, we will have the opportunity to see it, are of course the ports. Most of the coast is generally very well protected. They were also, in the previous project in 2011, the Master Plan for Coastal Safety, it was already addressed most of the weaknesses along the coast, but the ports were not included in that study. So this means that there was never yet a framework to look at the vulnerabilities coming through the ports. So the objective is to strive with realism, so to strive for a vision that includes a co-creation process. It has been, this phase of the project has been intensive workshops with stakeholders, so it was quite a process, a lot of discussions, a lot of different views, and of course integrated design studies. So we include the study, you will see a bit more on the ins and outs, but it includes a lot of studies, design studies, and we also look at feasibility. So we also look at costs and the legal aspects of the measures that we are proposing. And of course, when I said before that we go up to 3 meters sea level rise, you probably said, wow. Of course, that's not the most likely scenario. So we go up to 3 meters, but this is of course looking at the least likely scenarios where we don't change policies in terms of sustainability, that we keep on having an economy based on fossil fuels. We have such, so based on the data, based on the existing climate models, there is some possible scenario where we end up with 3 meters, but of course the most likely scenario is 1 meter. But there's some uncertainty on that, so there's a lot of uncertainty of how much and by when. So the main focus of the project is building adaptive capacity, where in some cases today there is none. There is no capacity, no opportunity to build on top or to make or a coast that is resilient. So as I mentioned, there was a lot of discussions with stakeholders. Stakeholders from the local government, from the regional government, also from the borders, France and the Netherlands, and of course the scientific community, all the businesses around the ports. There was a lot of intensive discussions, and these were really necessary to have a first set of possibilities that include all the views of all the stakeholders. Apart from the coordination, what did IMDC? So IMDC is a consultancy and engineering firm. We work on water-related topics. We also work on blue energy and water resources management. In this case, in this project, we designed and evaluated the protection structures. This design and evaluation was based on numerical modeling. We also did inundation models, assuming that the protection was destroyed. So we also did that. We redesigned the outer breakwaters hydraulically and structurally and geotechnical. We also did the environmental impact assessment, the first phases, and all things related to salt intrusion and so on and so forth. So it was a huge pack of studies that support the measures that we are proposing here. And the process, how we developed, so first we designed the protection measures and the alternatives. We made a spatial design, so we visualized all the alternative concepts. We assessed the different alternatives together with the stakeholders, and based on this reassessment, based on this assessment, we would redesign the structures. So the assessment is based on the framework of ambitions for Kustvisie, so having a coast that is sustainable, having a coast that is feasible in terms of costs and legal, and a coast that is attractive. Translate those ambitions into evaluation criteria, and some of these evaluation criteria were optimized and were further detailed during the optimization process. So we looked at technical feasibility, we looked at the hydromorphological impact, the ecological impact, the socio-economic impacts, nautical impacts as well on the ports, attractability of the coast, etc., etc. In terms of the outcomes, so now we have space requirements for each of the measures that we designed for the entire coast and for the 4 seaports in Belgium. And of course, linked to that, we have prospective adaptation measures that were consulted with the end users. We've developed these roadmaps. I will show them a bit in detail later. And we determine what are the tipping points and decision moments. So when do we need to start the studies to adapt the port? By when do we need to make these decisions? So we also determined this. So this slide here shows indeed, so for 1 meter, 2 meters, and 3 meters sea level rise, what are the critical sections along the coast of Belgium, and we see that even for 3 meters sea level rise, there are still some sections that are safe according to the standards established. However, if you see here, you see that all the ports, so the port of Zeebrugge, the small marina of Blankenberge, the port of Ostend, and the port of Newport, they are all susceptible and vulnerable to already 1 meter sea level rise. Can't see here, but this is 1 meter sea level rise. And of course, it will further aggravate in the future. So in terms of adapting to seaports to sea level rise, what did we do? We looked at the safety perimeter. So the safety perimeter is the perimeter towards the inland. Of course, most of the ports have urban tissue on the side, so therefore this safety perimeter is where the safety for the hinterland is located. And but we looked at nautical safety, the safety of the moored ships, and coastal inundation, so both inside the wave basin. And we look at the coastal hazards that we look at were waves, failure of the outer breakwaters, and overtopping. We also looked at the failure of some of the locks, inner locks that are located inside the port. I don't know how much you are familiar with the ports, the seaports in Belgium. So, as I mentioned, there are 4 ports. There is the port of Zeebrugge, which is a port that is mostly the outer port. I mean, it's mostly an industry port. So, but the other ports are within the urban tissue. So it means that they have to interact, and they actually have a good interaction and interface with the cities that are surround them. And another particularity is that in two ports, in the port of Zeebrugge and in the port of Newport, there are two natural wetlands that are with high ecological value. So that's also a good and interesting particularity of these ports. So we have one industry port, one that is a mixture, the port of Ostend, and two urban ports, the port of the marina of Blankenberge and also the port of Newport. In terms of adapting to sea level rise, the first question we had is whether we keep the port open or we close it with a storm surge barrier or a lock, or a concept that we've come up with, which is a kind of hybrid, which means it has a storm surge barrier and a lock. So, of course, if we keep the entrance open, it means that we need to reinforce the entire protection around the port. So, at first, the safety line, the perimeter for the coast, and we need to look at what is the impact on the operations of raising terrains, or can we propose something that is more an accommodation strategy by allowing some flooding on some terrains. You already know this and much better than myself, that of course this criteria depends also what kind of operations you have on the quay wall, what kind of operations and how can you cope with flooding on the quay wall. So, of course, when we have the urban ports, of course, we don't want this. We don't want to just put a barrier between the urban and the port. So, therefore, it's an opportunity to create different environments, different spaces where you also integrate nature, where you also improve the connectivity of the city with the port. And all these concepts were tried. You can have here, for instance, you can seal your port, and on the back you can have a nature park or something of the sorts. There's also an opportunity when we are adapting the ports. There's also opportunity, as in the case of Newport, where we have a completely new urban development and a new marina it's going to be integrated into the future. So this is already this will already be an opportunity for further development. This is options where this is the option of this is the port of Newport, where already they are constructing currently. It's in construction, storm surge barrier. The storm surge barrier, which means that there's a closed entrance to the port. For instance, in the port of Zeebrugge was not even, it was considered. It was not possible to place it, and it was also not an option that stakeholders like, because of course they want to have their port open. But in the case of Blankenberge, in the case of Ostend, we managed to be able to have different locations storm surge barrier. What is the great advantage? The great advantage is that it decreases the amount of construction that you need to do in your port and around your wave basin. This is some examples on how you can adapt for 1 meter, 2 meters, and 3 meters, and how the space can evolve in the process. As I mentioned, this is one case where you have already a nature reserve, and then you just within the adaptation you can still improve and upgrade that nature reserve, and improve also the connectivity of the city with the port. This is a case in the port of Zeebrugge, where well, you can't see it very well, but of course, raising the entire terrain is not possible. And basically you build in front. So, but of course, if you build in front, you take space from the navigation. And these aspects we also checked and considered. This is another example on the bottom, another example from the port of Zeebrugge and the Ro-Ro terminal, where, of course, there you also have the ramps, and you can't create obstacles you should facilitate the cargo in and out. So, yeah, these aspects, of course, we considered. This is some more examples, very similar. Here, there's also an example where we raised the floors of the buildings, and here again, where we include a nature park on our adaptation strategy. So one thing that it's very important in this exercise is these roadmaps and how we navigate from one adaptation strategy to the other. So basically it's something, so we go from, we are here in 2023, so we expect we will start the studies for this somewhere between 2025 and 2030. And there's, of course, some decision points. So first thing is, do we keep our port open or do we close it? When we close it, of course, we need to decide and we need to check when do we start the studies to adapt. And for each of these adaptation strategies and also tipping points where we decide for one strategy or the other, or we move strategies, we determine a tipping point for that decision. This is another example on the Port of Ostend. One important aspect in the Port of Ostend, also linked to the topic that we are looking at, is one of the most important terminals in the Port of Ostend, responsible for something like a third of the revenue of the port, is the renewables energy terminal, the REBO. And of course, having a closed entrance would likely hinder that activity, and therefore this was something that we discussed a lot. And not only we had to, with the sea level rise, we also had to adjust. The structures, the outer structures, and depending on open or closed entrance, you also need different sorts of space beyond that barriers, because you need, for instance, safe and rescue teams that need to be outside. It's a project, as I mentioned, that will continue in the future, so we have not yet come to a conclusion. We are now looking at, refining our cost estimates. We are looking at possibilities for the storm surge barriers, the cost. And, but I leave you here with the objectives of the project, which is having a protected coastline, a forward-looking coastline, an attractive coastline, and finally a viable coastline. And this, of course, includes the ports which have challenges of their own. Thank you.
Any questions for Luciana? Mr. Eduardo Feio, the President of the Port of Aveiro.
Just one question about what is the draft of the port that you are intend to close, the new port, the draft?
New port is -7 meters, something like this. Okay. The barrier is a segment door, and it has a height of 15 meters.
15 meters.
It's
okay.
quite substantial, yes.
Yes.
And I think it's 35 meters.
35?
Yes.
35, okay.
35.
Okay, thank you.
Any other question? No more questions? Oh, one question from Cantabria, the north side of Spain.
Thank you, Luciana. Well, I have a question regarding the implementation of those adaptation pathways. How do you decide which is the moment? Are you basing that decision at your, just in the sea level rise, or you are taking into account economical consequences? Or?
Yes, so one thing that this exercise is really good is that it gives you the roadmap. That's the main thing. But of course, looking at the costs, and of course we have now a cost estimate which I will not communicate, but we are now refining it. And one of the refinements can be coupling these adaptations with other needs that you are already implementing in the port. So I think that's the next step. Looking, of course, now we looked at the operations, for instance, in terms of criteria for designing the structures. This was something that we had to discuss with the stakeholders, because it's not the same having the Fluxys terminal, which is an LNG terminal, or having the container terminal. There's completely different needs. And of course, we also need to look at what is behind. But so one aspect is this, and the other is indeed to couple some of these adaptations together with other needs inside the port. Yeah. So we definitely, I think this roadmap gives the port authorities that vision, which otherwise it's not possible.
Is there any other question for Luciana? No questions? Thank you very much.
Thank you.
After speakers who brought us different visions of different issues, we are going to return to Spain and now to Galicia. Gerardo González is Head of Works Division from the Port of Vigo. Gerardo González Alvarez works as Head of Infrastructures, is civil engineer. He has been working for the Port of Vigo for the last 4 years. And his previous experience involves working for a major construction company, both in Spain and for international projects in Europe, Middle East, and United States of America. He is currently involved in several projects related to coastal and marine infrastructures. Gerardo González, por favor.
Well, thank you for the opportunity to be here to Portos dos Açores. And thank you, in my case, for the opportunity to be here speaking about the Port of Vigo. The Port of Vigo is the closest general interest port to the border with Portugal on the north side. And I'm going to talk the impact of renewable energies in the key performance indicators and how that leads us to the green port goals. Well, here you have some general figures about the Port of Vigo. We are in northwest. We are in the bay of the same name of the city, Vigo. So we are a natural shelter port in harsh weather conditions. We are a very diversified port with going from east to west, container terminal, commercial docks. We have a cruise terminal, fishing port, obviously, which is quite important in Vigo, and a ro-ro terminal. And in between all of these, we have a quite powerful shipbuilding industry. The fishing port, and the fishing industry creates 4,000 direct jobs and moves on the verge of 700,000 tons of fish every year, so it's quite important. And with all this, there is a concept that is quite important, is the blue economy. We have been working in the blue growth strategy for some time, and it's quite important to understand that what is blue economy. For example, there are ports that move huge amounts of, for example, iron ore in the north of Brazil, but the iron ore comes by train from far away, is loaded on big ships that then take the iron ore to the other end of the Atlantic, where it is processed. So the actual revenue of those movements in the hinterland of that port is small. That compared to ports where most of the goods are sourced or produced locally, where the impact in the economy is really important, in the economy of the city and the hinterland. So if we are able to create actions that promote sustainability in economy, social, and the environment, we are creating that blue economy for the port. Obviously, as an administration, we are the Port Authority, but we need the input from the academic sector and the private sector to get the big picture, to get a real understanding of what we have to do to be sustainable. So we have been collaborating with many stakeholders. We had 59 projects going on, 300 participants, and that evolved into 6 permanent commissions. And obviously, for today's topic, the Blue Energy and Shipbuilding Commission is sorry. Thanks. So we continue. I was saying, okay, so focusing on the key performance indicators, what we want to analyze today is the green port. So we would focus on those, that green line of KPIs, and mostly on the first 3 ones, which are the first one is reduction of energy consumption in port facilities. Second one is the clean and self-generated energy. And the third one is the reduction of emissions of greenhouse gases. The 2 figures that you see there are the goal and what we have achieved already. So we are in 17% for the reduction of energy consumption. Sorry again, I didn't touch anything. Is it something here?
This button, I don't know. Perhaps it's what's causing.
Okay. So 70% for reduction of energy consumption, 3.3, so we are over the goal, and 30% for the third KPI, which is quite good. We are there. With regards to the first one, the reduction of energy consumption in port facilities, obviously, on the left, you see that blue chart. We cannot impact or decide what to do with the private sector. We don't gonna decide what the owner of a ship is going to install in the ship to reduce the energy consumption or their decisions. So we only have power to decide on our own facilities and premises. So we have focused our efforts on, you see, I'm not touching anything. So we can only, I will keep explaining. We can only decide on our premises, so we focused our intentions on lighting systems, the refrigerating systems in the fishing port, the ones that we manage, and our own offices and premises. There are several projects that are already finished, like the improvement of the energy efficiency in the fishing port, in the Lonja, new lighting systems in the Bota Roro terminal, that means changing all the lighting systems to LED lighting, lighting systems in the commercial docks, and energy efficiency in our own offices. those energy efficiencies combine the lighting systems, the refrigerating systems, also the improvement of the thermal enclosure of the buildings. And then we have another projects that are ongoing, which are the energy efficiency in the fish market and new lighting systems in other terminals. With regards to the second KPI, the clean self-generated energy, we have quite a strategy in these solar photovoltaic plants, and we have been working with this idea for a long time, although our plants are quite small. So we have already installed like 300 kilowatts of power plants, solar power plants in our buildings, and we have another like 400 kilowatts projected, and also a small windmill in the Ro-Ro terminal in Bouzas, because it's the more exposed area of the port where we will get more wind. There is a project that I would like to explain a little bit more, which is the energy efficiency in the fish market in the Lonja, because we are quite proud of the results, and I think it sets a path that we should follow in future actions. First of all, I would like to explain these two buildings, the Lonja and Mercado. These are in the fishing port, and the particularity is that the Lonja, the big building on the left, includes the auction hall. It's a single, huge, massive space of 36,000 cubic meters, where the first sale of the fish is done. And then the Mercado has another auction hall, smaller, but it's still big enough, with 19,000 cubic meters. The dynamics established between these two buildings is that the vessels come from the sea with the fish, and they unload their captures in the Lonja. And after the perceptive controls, that fish is sold in single species lots to wholesalers. And then those lots are either taken to their premises or transported to the Mercado to be sold in that second sale in smaller lots to retailers or restaurants or other kind of small clients. So we detected that in these buildings we had deficiencies. The cold chain is key for the quality of the fish that we are selling, so maintaining that cold chain is key. And we were working with temperatures of 12 to 16 degrees even in winter. We had equipment that was dated and not efficient, and lots of holes in the facades, not necessary. So we were losing a lot of energy, and we were not being efficient. We set a couple of goals. First, reduce the carbon footprint of the Port Authority by increasing the use of renewable energies. And the second, achieve a set point temperature of 8 degrees Celsius, which is a temperature fixed by regulations in Spain. Obviously, the first goal is just a general goal for the Port Authority, and the second one is very specific to this project. We propose solutions that, well, for the second case, let's go for being efficient. The improvement of the thermal enclosure and a new cooling system. The thermal enclosure, you can see in this picture on the top side of the slide. That white area with the door, with the two doors, used to be two big doors, a pedestrian door, plus a polycarbonate panel on top, which was not insulating at all, so we were losing a lot of cold air through those holes. We had 14 of those doors, 14 times 2 plus the pedestrian door, so it was a massive loss of cold air. We analyzed the dynamics of the unloads of captures, and it was not necessary to have two big doors for each gap, since when we have a boat docked on the side of the Lonja, there is just one single forklift moving the fish in and out. So there's no possibility of a crash. With one door, we're done. And then the pedestrian door to have safety when walking. And then obviously closing the top part with an insulating panel. Then the new cooling system is much more powerful. more than 2,000 kilowatts of freezing power, 24 fan coils, and a new refrigerating tower. So great, we have 8 degrees, we have everything really tight with combined sliding doors and high-speed doors, but this system is much more powerful than the one that we had before, so it's going to need more energy. So how we solve it? With a dedicated photovoltaic plant on the rooftop of the Lonja. We installed more than 300 solar panels, 3 solar inverters, and 20 batteries. With this power plant, which is capable of producing, in real numbers, 147 kilowatts peak, what we've achieved is that the previous consumption, without the solar power plant, we were using 1.4 million kilowatts a year, and now we are using 1.17 million kilowatts a year. So we're saving around 15% of the total consumption of the 2 buildings, and with a lifespan of 25 years. It's quite important understanding the dynamics of the work in the Lonja and Mercado, and it is that the main activity happens at night. So we're not producing solar power during the night. What we do is, with the solar power, we cover the whole consumption during the day, plus we charge the batteries. So at night, when the freezing equipment with the refrigerating equipment starts working, we cover the first hours with the batteries, and when they are done, we continue consuming from network with a very favorable price. So in the end, we are saving a lot of money. Favorable price compared to the daytime fare. Okay, now in other actions from the port, we have this Green Bay project, which is promoting the use of alternative power units, new construction, new ship construction, and alternative fuels to reduce the emissions of greenhouse gases. We did some tests in the past with LNG. We are working nowadays in trying to, it was spoken several times today about the OPS, and we are trying to have funding to install a new dedicated line to the cruise line terminal. So we have several actions in that path. Also, the Julio Verne project, which is a green hydrogen project in Vigo. It was funded with 2.4 million, and it involves a bunch of local companies, small companies. So we were trying to start the whole chain for the hydrogen in Galicia with this project. And except for very, very specific equipment, most of the project is being built in Galicia and specifically around Vigo. So we are really happy with this. It should start producing hydrogen by early next year, early 2024. So with this reduction of greenhouse gas emissions, the European Green Deal and the 55% by 2030, there are 2 approaches we can take. One is the emissions reduction, and the other one is the compensation and mitigation. With the emissions reduction, what we said, we can reduce the energy consumption, we can generate clean energy, and also we need to analyze the data. It's key to understanding where we are. So we developed 2 tools to help in this. One of them is the Port Carbon Footprint Calculator, which does exactly that. It's a carbon footprint calculator, and it's available to anyone in the port community that is interested. And also the Green Logistics. Green Logistics is goes one step further, and it's a tool where the companies established in the port ecosystem can provide input on their type of activity, the energy consumption, and several other data, and that tool provides a possible solution for the use of renewable energies. It defines a basic solution in renewable energies for that kind of activity. And with regard to compensation and mitigation, we have also some projects going on, most of them linked to the Peiraus do Sol Port strategy. Right now we have just finished the second leg of this strategy, which is called, sorry, this is a couple of screenshots of the tools that I just mentioned. We have just finished this second leg of Peiraus do Sol Port, which is called Living Ports. And it's a project where we are intending to create or develop infrastructures that imitate natural habitats, so we can build new infrastructures without destroying habitats, but creating them. What you see here is not a render, it's a real photograph of the observatory that we call Nautilus. It's, let me say it this way, an upside-down aquarium where you go inside, it's floating, and you go inside and you see the surrounding basin in our port. On the right side, you see these panels that are built with bioengineered concrete. It's a patent from an Israeli company called eConcrete. On the left side is just the actual basin from our port. So, many actions taking place. Thank you very much. If you have any questions.
We will open a new space after this presentation for questions from the audience. Any question, please? From Portos dos Açores, Paulo Soares.
Hello. Thank you for your presentation. About that last slide that you showed, the port footprint, carbon footprint calculator. How did you develop that? Did you use environmental specialists, or was it in-house?
Right. It was in-house. We have the sustainability department, which is, I would say, for our standard, which we are a small port, the sustainability department is quite big, and the in-house professionals develop these tools. Actually, the chief of the department, Carlos Botana, is the one that set the guidelines for these tools. Yeah.
Are there any other questions?
Thank you.
Thank you, Gerardo. And for now, a short 15-minute coffee break follows. We'll be back in a little while. Thank you. Also, the Governing Board and Management Committee of the Conference of European Roads Directors. Eduardo Feio has a degree in regional and urban planning from the University of Aveiro. He is currently, by virtue of his duties, a member of the board of the Association of Ports of Portugal. Mr. Eduardo Feio.
Good afternoon. First of all, thank you very much to Port Project and the Ports of Açores for inviting the Port of Aveiro to be here today in the afternoon to speak about our action plan for sustainable and production and storage of renewables. I'm going to try to make a presentation of the port and what you are doing in that area in Aveiro. In 20 minutes, I think it's time that I have. Let's see if I can manage it. So I think that a lot of people know where is Aveiro. Aveiro is in the center of Portugal. For that don't know, our hinterland is the center of our country. We have always relations with part of Spain. We have a very good relations with Salamanca, for instance, and that is the area that we are. The administration of the Aveiro port is also the administration of Figueira da Foz port. So we have a foreland in Aveiro that is almost all the world, and you are going to see why that. That is our area of the port. We have more or less 2 million square meters. It's the second biggest port in Portugal after Lisbon. A lot of people don't do that. We have a multi-use port. We have nowadays are making more or less 5.7 million tons every year in Aveiro and 2.2 million tons in Figueira da Foz. So you have the management of the two ports, and we are very committed in the offshore industries, in Aveiro, in all the electrification of the ports. And as you can see, we have a very multifunctional port. We have a part, that part here, that's the old part of the port in Aveiro. It's the port that have more than 55 years. That area is the last of the fishing ports of Portugal. It's the port that we can do. Everybody normally eats some cold in Portugal during the holidays, in Christmas time. Always, normally it comes from that port. And we have that, the new part of the port. We have a chemical part of the port. We have also the multi-use port, and we have that blue area there, where it's there that you have a lot of industry that are coming to work essentially in the offshore industry. So you have the biggest factory of towers for offshore in Portugal, and one of the biggest in Europe nowadays, the CS Wind. And for instance, every day in the Aveiro port, we have a blade that go away for the north of Europe. At this moment, we are putting blades for the industry that are installed in the area of Aveiro, in Sweden, and also towers. We are going now putting some towers 2 and 2 weeks to the North America, offshore areas. So that's our scope, to work very hard in every areas of the port. So, as I say, we are making 5.8 million. We have more or less 100 vessels a year. We have a lot of areas for storage, as you can see in pictures, and we do a lot of chemics. Nowadays, Lisbon and Aveiro are the ports in Portugal that do more chemicals. So that's the evolution of the cargo. Everybody knows that during the pandemic times, all the ports have a little down in cargo. Now we are getting better, but nowadays, and if you see the news, the ports are also getting a little bad. For instance, in containers, in Iberia, we have not the traffic that you used to have, but the ports are changing to a new business, and that is our profile. You are a port of import. We are an industrial port, essentially, so we import more than we export from the Aveiro port. And because of that, we try to, and as you have been listening during all these days, and for me it's very good to be here because I'm learning a lot of things. I'm only in 9 months in this position, but as you know, one of the principal projects that we must have is the decarbonization of our ports, and electrification is a very important instrument for that. We have obviously the European Green Deal and other regulations that we are compliant to do. We have also the port's active role in the business and the generation. Normally the ports in Portugal are entities that sell energy. I don't know if in Spain it's like that, but normally we buy and sell the energy to everybody that are in the port. And we have obviously very precise goals that we have listened. In the more or less 10 years, we must have much less energy getting by fossil. And in the middle of this century, we must have zero energy by fossil. That's very, very ambitious, and you have a lot of work to do. So we try to make a mix of energy, renewable energy in the Aveiro port, sustainable in the aeolic energy, and also in the solar energy. So first of all, we have to study, and we study a strategy for trying to get that target. So we make a feasibility studies. You make energy strategic transition. We define lines for action. We have projects, development and selection for funding. We have partners, and we have a separate location for clusters of energy and offshore energy support, as you already said and you already see. So that's our target, so zero in the middle of the century. And so the study that we make with our University of Aveiro and other consultants says that we have to increase our renewables energy mix, to increase the consumption due to the decarbonization process and new customers. So are going to need more energy. And obviously the onshore power supply, it's very important to all the business that we have and to supply the vessels in our berths, in our piers. Several medium and long-term scenarios were defined and studied. And we have here what is going to happen in the future in Aveiro. For instance, we have also a very important industrial area, so that will need more energy, not only the normal port operations, but the new factories that are going to the port need more energy. So we make the study, we study different scenarios, the grid energy, the renewables, the energy storage. Obviously, you need to get high voltage in the port. That's a very important project to get energy to the port. We have seen, listened all over the morning how can you put the cable from the substation to the port? We have the same problem in Aveiro and the cost of that cable. And obviously, the money that we must spend in that. The studies that we have, they have some results. The first result was the renewable energy port community has the potential to optimize the use of renewable energy by sharing it between members, avoiding surpluses, reducing energy costs, and reducing the port's carbon footprint. That's very important. It's not only the administration of the port, but all the community that must be involved in this situation. And we have lucky because we have a lot of companies that are already in the port, that they have their own strategies for renewable energy. For instance, for solar. For instance, everybody knows PRIO. It's also in biodiesel products, and we are speaking about that in little slides in front. So then can get the scale that we need for our project. And obviously, after that, we have to make and build an energy management system. We'll need to monitor and manage and optimize the consumption to the day. That's very important, the way that you can make the management of the situation. We have to have some tools for that. So that's our strategic transition vision in a very simple way. An efficient and digital way to promote energy efficiency, the use of resources of renewable origin, the seamless flows of goods and interconnected mode of shift. That's very important also for the business of the port. If we get this third objective, it's good also for our business in the port, not only for energy, but the operators will be very pleasant to work in a port that is quickly. The car will not stay there many times and go to where it must go quickly. Its economic growth, social development, and environmental quality improvement through the meetings of the United Nations development targets that we have also listened from that targets during this morning. So the roadmap is here very summarized. The energy service, the port advanced biodiesel, the efficient energy, the green land use concept, the efficient logistics and chains, the digitalization, the port community network, smart port cities, and business investments and funding opportunities. And that is the green energy urbanization platform. We must have the batteries, storage, the electric vehicles. Nowadays, our float is almost all electric in the port to do normal works. The ferry charging, we are going to have the first electric ferry in Portugal, in Aveiro, to be operating during this year. It's a project of the municipality of Aveiro. Obviously, onshore power supply, the new equipment and port electrification, the renewable energies, and the digital substations. So the mix that we have, it will be windmill, PV panels, and storage to try to get in our microgrid energy and the port community. The port energy service, we are going to deploy, and we are in the process to see how the other ports work, the solutions that we have, for instance, in North Europe, and to deploy a mobile onshore power supply of 50-60 hertz to supply ships at berths, as well as other port facilities, equipment, and vehicles. That's very important. You are not, for instance, a port that have cruise there, like here in the Açores or in the Leixões or in the Lisbon, but it's important for the container ships that you have not met, but all ships in future for sure will need to get energy, electric energy, and we are going to prepare our port for that. And also the other area that we are working, and we are working with ports in Portugal, for instance, with Leixões, it will be biodiesel fuels. Previously it's working with that. We are making some experience with our pilot boats, with the port equipment that are already working with this kind of fuels. And obviously we are trying to do with some vessels, and for instance the vessels that take the fuel to the port for fuel transform, are going also to use in future some biofuel. That's very important to get our targets that we have speaking during all this morning. And so we are trying to get, obviously, I speak about the car fleet, we are speak about all the lights in the port. We are at this moment in the end of a tender to invest more or less 0.3 million euros to transform all the illumination of the port with LEDs, because we have a traditional way. Now we are going to LEDs during this year, and we are going to save a lot of money and also a lot of tons of CO. That's very important. And also the installing solar panels for self-consumption in the area of the port. We already have some in our administration area, but we are going to improve that. And also trying to, in the future, to have aeolic to support also our strategy for the decarbonization of the port. But none of this is possible if you don't have money. And we are speaking a lot of a very big investments, and you have the chance. For instance, with PRR in Portugal, we are going to put more than the numbers that we see there. There are considerable numbers. And we are also, from our own money of the port, trying to put some money to have really a port that worked all days to get the targets that the Europe appoint, that the national government appoint, and better than that, that we really need to have if you want to continue to live in Portugal well, if you want not to have that kind of projects that take to make more protections in coast, because in the end of the day, we are not speaking only about electrification of the ports, we are speaking about our quality of life, we are speaking of decarbonization, we are speaking about climate changes, and we are speaking to preserve our way of life and improve our way of life, not having to spend a lot of money in future with big projects that trying to mitigate, but in some way it would be the way that we have if you don't improve all these areas. The other area that's very important is not only decarbonization, but is digitalization. And it's very related, one thing with the other. In future, in the morning I say that it's looking, we are going to deal and do business with data. More than cargo, our business in future will be data. We must prepare ourselves for that, our human resource in ports, and obviously the data here have a very big relation with energy, with the management of the energy grids, the renewable energies, the affectation of the cargoes, everything to be in data. We must have the people, we must have the mental to that situation in the ports to try to get our goals that we have. We have already some experience in Aveiro with digital twins for management of cargoes in some projects that we have made with Vodafone and Ericsson, like in Livorno Port. But we must think also of that instruments in the area of energy and management of energy. So the conclusions that I have, and I think that I've spent more or less 15-20 minutes, not more, and the Port Authority should lead the actions of science to being an example to follow for all these stakeholders, especially those who integrate this port community. So it's very important, port community, not only the public administration of the port, but the port community, in order to contribute to the achievement of the European Green Deal targets and the emissions reductions. And the port community, in some ports, it's very important to deal and work with the city that normally the ports are in the city. In case of Aveiro, it's a little bit different, but in Figueira da Foz, it's not. It's very important to have a very good articulation with the city and the municipal community, obviously, for these kind of targets. Therefore, to accelerate the development of innovative green solutions towards the green port of the future, it's not enough to the meeting of port authorities. The whole port community must come together to tackle the current issues in order to have an effective greening of the whole waterborne transport value chain. Therefore, it's crucial that the medium small ports that we can consider that Aveiro is, but it depends of the point of view that you have. I think that now it's getting a bigger and a bigger port because of the importance for a lot of years. Are also able to follow this path at the same place as the last ports, leaving not a single port behind. Technology and financing resources need to become available to implement the energy transition strategies. Not every port has the PRR, but I think that state and must get resources, European resources, national resources, because that's a central project for the quality of our life and for the quality of the future. So, thank you very much. If you have any questions, I think.
As usual, we open the possibility for questions being asked in the end of this presentation. Any question, please? No questions?
Cool. It's everything clear, so let's get produce some energy. Renewable.
Okay.
Okay.
Well, to end our program today, we are going now to Madeira's sister archipelago to find out how Madeira will supply cruise ships with renewables. The speech is by Bárbara Vieira from APRAM, the administration of the ports of the autonomous region of Madeira. We will try to listen to Bárbara. She is in Funchal, in Madeira Island. I hope you can hear her. I'm not sure if we are going to see Bárbara because she told us there's a little problem with the webcam. Anyway, Bárbara, are you there?
Yes, I am. Are you hearing me?
Okay, go ahead, please.
Okay. So good afternoon, everyone. First of all, thank you for the invitation to participate in this seminar. I apologize for not being able to be there today. However, I appreciate the opportunity to share what we are doing in the ports of Madeira. So, as said, my name is Bárbara Vieira, and I'm currently working as a senior technician at APRAM, Administração dos Portos da Região Autónoma da Madeira, and I'm here today to tell you a little bit about the Green Ports Madeira project, which we are currently developing. But first, I would like to talk a bit about the autonomous region of Madeira. For the ones of you that don't know this archipelago, Madeira is made up of two sets of islands with no population, the Desertas and the Selvagens, and two islands with population, Madeira and Porto Santo, which from the pictures you will be able to see that are very different from one another. With an area of about 800 square kilometers and a population of around 250,000 people, Madeira is known for its mountains, forests, and beaches. So, APRAM is the port authority of the autonomous region.
Bárbara, please, we are looking just for the first slide. Can you scroll for the other ones?
Yeah, I'm seeing the other ones. Let me just try again.
No, Yeah, we are at the first slide of your presentation, yeah?
Still in the first slide?
Yeah, yeah.
Let
Yeah.
me try. And now, can you see the second one?
Yes, that's okay for
Okay.
us. Thank you.
So, and now the third one.
Yes,
Okay.
that's okay.
So, as I was saying, APRAM is the port authority of the Autonomous Region of Madeira, and within APRAM's areas of jurisdiction, there are commercial quays and private terminals, such as the Socorridos terminals, with an annual movement of solid bulk of around 70,000 tons, the Porto Novo terminal, which moves about 180,000 tons of inert materials per year, and the CLCM terminal of Madeira's fuel company, with a movement of over 300,000 tons of liquid bulk every year. APRAM also manages several other smaller piers all around Madeira Island, which are used by small recreational vessels and artisanal fishing boats. However, the vast majority of operations take place in the three major ports of the region, the Port of Funchal, the Port of Canissal, and the Port of Porto Santo. The Port of Funchal is the main port for tourism in the region, having handled last year around 400,000 passengers in about 300 calls. The Port of Canissal is the region's main port of supply, with a movement in 2022 of around 1.2 million tons of cargo in almost 250 port calls. The Port of Porto Santo is the island's main point of entry for goods, having handled last year around 25,000 tons. This port has been growing in terms of cruise ship tourism in the recent years, having reached in 2022 an annual movement of more than 3,800 passengers. Also worth of mention is the inter-island traffic, with about 300 calls last year, and the movement of about 340,000 passengers. Given that you all have some information about Madeira and APRAM, I will move on to talk about what brought me here today, which is the Green Ports Madeira project. As you probably are all aware by now, there has been a growing concern about shipping pollution. And APRAM, as a port authority and as an entity whose work focuses mainly on the ocean, are aware of this problem and have been working to keep up with the policies of the Fit for 55 package. So when we heard about the European Union funding initiatives within the scope of maritime transport, we decided to submit an application so that we could develop a project that could help us meet the ambitious goals of the Fit for 55 package. Therefore, we decided to join forces with the electricity supplier of Madeira, which is Madeira's publicly owned electricity company, to develop this project, and gladly receive some support of a task force that assembles all the main regional stakeholders, like the municipality of Funchal, the regional government, and the ferry line operator, as well as the cruise industry, particularly from the Cruise Lines International Association. The Green Ports Madeira project fits here in the terms of the local strategy to meet EU goals. It will allow to study the provision of green service to the shipping industry and meet EU targets and commitments for decarbonization by reducing greenhouse gas emissions, air pollution, and noise. The main ambition of this project is to study the preconditions to decarbonize the three major ports in the Madeira region, which will mostly be done through the assessment of the feasibility to introduce onshore power supply. This project has an estimated duration of 2 years and a total cost of about 1.2 million euros, with 50% being funded by the European Union. Taking into consideration all the aspects related to energy and electricity distribution, we embarked on this project together with Madeira's electricity company, which is our partner in this challenge. It is important to say that although emissions at berth represent only a small fraction of total maritime transport emissions, they need to be addressed, particularly when ports are located within the city center, such as in the case of Funchal. OPS is an important tool for many ports to lower emissions from vessels at berth, and it's therefore a key instrument for decarbonizing ports in Madeira. Nonetheless, it is important to bear in mind that the installations need to be connected to the grid and preferably rely on electricity from renewable sources in order to ensure effective emissions reductions. That's why this project will investigate ways to use energy from renewable sources, but also to co-produce energy in the port and, if possible, on offshore facilities. Also, the project will further study the viability of retrofitting some of our own vessels to run on low emission energy sources and focus on the potential of ports as green multimodal hubs, bringing additional added value to the communities in their vicinity and opening up the potential for energy supply to electric cars, buses, and freight delivery trucks, decreasing pollution both within the ports and extending beyond their area of influence. The project will further study the environmental impact assessment of the measure found to be the most appropriate to the reality of Madeira. This will strengthen the choice of the proposed options, quantifying the impact of each measure in the region. It is also important to state that the project will not only contribute to some of the UN's Sustainable Development Goals, but also, and we hope, to provide a blueprint for other ports that struggle with specific constraints that arise from remote geographical location and insularity. In order to achieve the objectives we set for ourselves, the project was outlined in 5 work packages. Work package 1 is the project coordination, and it will support the entire project through ensuring that it is delivered on time, with quality, and within the budget. Work package 2 is called Greening Up the Ports of Madeira, and it will focus on developing the role of ports as green multimodal hubs, on studying solutions for widening zero-emission power supply, and on the development of OPS solutions for the ports of Porto Santo and Caniçal. Work package 3 is named OPS for cruise ports and will focus on cruise ship operations, understanding the potential for powertrain adaptation for tugboats and pilot boats to run on more sustainable fuels, and studying the development of OPS solutions for the port of Funchal. Work package 4 is called Studies to Support Future Development and will build upon the findings of the previous work package, studying the environmental impact of OPS implementation, further preparing the requirements for tendering works for the subsequent project of infrastructure development for OPS service supply. Work package 5 is the communication strategy and will provide a communication link with stakeholders, being responsible for sharing the key findings of the studies, engaging with the different stakeholders, collecting feedback, organizing events to raise awareness on the importance of OPS technology, amongst several other actions. Taking into consideration the dimension of a project like this, it was necessary to carry a prior risk analysis, and some of the aspects were considered. The risk of delays in the activities, the loss of part of European co-finance, the lack of coherence of study results, the risk of insufficient subcontractor performance, and results showing no feasibility to deploy OPS in the Madeira region. This last issue is extremely worrying for us because although the outermost regions are exempt from some of the provisions of the Fit for 55 package, We should bear in mind that the ships themselves have their own environmental targets and objectives within this package, and if we do not want to lose competitiveness in the sector, we must be able to offer alternatives to these ships. Being that said, I would like to point out that Madeira's main economic engine is tourism, accounting for almost 21% of the gross added value and 20% of employment. And cruise tourism is one of the most important maritime activities in Madeira, being able to offset traditional tourism seasonal cycles with the high season of cruise passengers lying mainly in the period between October and April, and the peak occurring in December, as a result of strong demand driven by tour package offers for the New Year holidays. According to the European Seaports Organization, even though many European port authorities are willing to deploy OPS to facilitate the greening of shipping, they face many barriers on doing so. The apparent lack of economical viability for OPS is the most prevalent one, as the cost for developing OPS in ports varies from port to port, but also from location to location within the port. Nevertheless, the current overall cost is high, with almost no return on investment for the investing party. ESPO also confirms that so far there are no cases known where OPS has been deployed on a commercial basis, not even in countries where renewable electricity is more affordable than the fuel used on board. Although this financial risk is not directly related with the studies, but rather with the following works, it is important to point out that such risks become more significant in the case of the outermost regions, since transport costs in these areas result in nearly 20% extra costs for deployment of renewable energy solutions than in continental Europe. This creates a strong economic barrier for the penetration of renewable energy in the outermost regions, which somehow we'll have to overcome. That's all I have to share with you today. Thank you so much. I will respond to some questions if you have some of them.
Thank you, Barbara. If there's any question in our audience, please notice as of your interest. No questions? Thank you, Barbara.
Thank you so much.
Well, I think this is the end of our meeting today. This is how we close our seminar. We thank everyone who was here for their presence. We also thank you, more than 24 people that follow us via YouTube. And for closing this day, the President of Portos dos Açores, Rui Terra.
Só para agradecer a colaboração de todos. Thank you all for being here, for collaborating, for introducing very innovative and very producing teams for the future, for our future, for the future of all. Tomorrow we'll continue with our roundtable, and of course everyone is invited to enjoy and to participate with us. It was a real pleasure to hear all the speakers here today. I speak for myself, I had no idea so many wonderful and innovative projects were being done around the world. There are more for certain, but for us here in the Azores, as you see, it's a wonder place, it's a marvelous place to work and to live in, but information takes time to get here. And people with your skills are very important to us, and it was very good to share the day with you. So thank you all. Hope to see you here tomorrow, and have a good, nice rest of the day. Thank you very much.